Example 2. Pre-employment drug screening. Find the following using the table below. Here we have two rows, which are subject uses drugs and subject does not use drugs. And then we have the two columns that represent positive test result, where the test is showing drug use. And then we have a negative test result, where the test shows no drug use. So here are the particular numbers. So first thing we should do is in a table is find the totals of the columns and the rows. So if we want to find the total of the positive test result, we're going to take 45 plus 25, and that's going to give us 70. If we want to find the total that a negative test result has shown, 480 plus 5 is going to give us 485. Now if we want to find the total of the subject that uses drugs, we take 45 plus 5, and that gives us 50. If we want to find the total of subject that does not use drugs, 25 plus 480 is going to give us 505. Now if we want to find the overall total in this particular study, we can either add the two rows together for the total here, or the two values for the column to get the total. So 505 plus 50 gives us a total of 555. Okay, now it's important to do that before each problem, something like this, because you're going to use these numbers somehow, some way in a particular problem. You may not use all of them, but it's good to get familiar with it. Okay, now for part A, it says, if one of the 555 test subjects is randomly selected, find the probability that the subject had a positive test result given that the subject actually uses drugs. That is, find the probability that the positive test result provided that the subject already uses drugs. Okay, so that means we're looking at the positive test result for the column here and the row, which is subject uses drugs. Now the intuitive approach, we want the probability of the positive test result given that the subject uses drugs. So if we assume that the selected subject actually uses drugs, we are dealing only with 50 subjects in the first row of the table. Now among those 50 subjects, 45 over here had a positive test result. So we would get this result. We would say the probability of the positive test result, which is 45, and we're going to divide it by the value of 50, which would give us 0.900. And again, in this case here, provided that the subject uses drugs. Okay? Now we're going to go ahead with the formal approach. The same result can be found by using the formula given with the formal approach. Okay? So here, what we see here is the probability that the subject uses drugs and had a positive test result. So the way to look at that is the following. We're going to come back up here, okay, and we want to figure out, okay, where, so we know that the subject uses drugs is 45, and also it says and had a positive test result. So that means it had it and also had a positive test result, which is going to be 45 out of the total 550. And it says the probability that the subject uses drugs. Well, the total amount of the subject that uses drugs is 50. So that means we're going to have 50 over the total of 555. Okay, so now what we're going to do is we're going to substitute this into our formula. So the probability of event B, provided that A has already occurred, is equal to the probability of A and B divided by the probability of A. So we're looking at the following. The probability that a positive test result given that the subject uses drugs is equal to the probability that the subject uses drugs and had a positive test result divided by the probability that the subject uses drugs. So what we're looking at is the following. Okay, we have that 45, which we said is the subject uses drugs and had a positive test result, which is 45 over that 555. And then we have the total of subject drugs, which is 50, divided by that 555. Now, if you notice that 555 can be simplified, meaning that you have a fraction over a fraction, so that 555 is going to be simplified to 1. So then what's left is 45 over 50. By comparing the intuitive approach to the formal approach, it should be clear that the intuitive approach is much easier to use, and it is also less likely to result in errors. The intuitive approach is based on an understanding of conditional probability instead of manipulation of a formula, and understanding is so much better. Okay, let's go to part B. If one of the 555 test subjects is randomly selected, find the probability that the subject actually uses drugs, given that he or she had a positive test result. That is, find the probability that the event of subject uses drugs, provided that he or she had a positive test result. So again, here we want the following. This is a probability that the selected subject uses drugs, given that the subject had a positive test result. So if we assume that the subject had a positive test result, we are dealing with 70 subjects in the first column of the table. So let's take a look here. We want to find the total. So the total of the column for having a positive test result is 70. So we would say that among those 70 subjects, right, how many had a positive test result that uses drugs? So going back over here, the subject uses drugs that had a positive test result is 45. So it's going to be 45 over 70, which gives us 0.6428571, which rounding into 3 decimal places gives us 0.643. So now let's take a look at the interpretation of Part A and Part B. Okay, so for Part A, the first result of the probability of the positive test result, provided that the subject uses drugs, was equal to 0.900. Indicates that a subject who uses drugs has a 0.900 probability of getting a positive test result. The second result of the probability that the subject uses drugs, given that they had a positive test result, is equal to 0.643, indicates that for a subject who gets a positive test result, there is a 0.643 probability that this subject actually uses drugs. Now note that the probability of the positive test result, provided that the subject uses drugs, does not equal to the probability of the subject that uses drugs, given the fact that there's a positive test result, because these two probabilities are not equal to each other. So what this shows in general is that the probability of event B occurring, provided that A has already occurred, does not equal to the probability of event A provided that B has already occurred.